Jupiter is a giant, a colossal presence in our solar system. It is the largest planet in our solar system, dwarfing all the others with its immense size and mass. Jupiter is also home to a vast and diverse family of moons, each with its own unique characteristics. In fact, astronomers are constantly finding new moons orbiting Jupiter, adding to its already impressive collection. This gas giant might have hundreds of moons in total, each one contributing to the story of our solar system. Each moon has a story to tell, from the largest to the smallest, from the volcanic to the icy. Some are large and covered in volcanoes, with fiery landscapes that are constantly changing. Others are small and icy, with surfaces that glisten in the distant sunlight. Today, we will learn about one of Jupiter's smaller moons, a moon named Philophrosyne, which has its own unique place in the cosmos. Philophrosyne is very far away, orbiting at a great distance from Jupiter. It is also quite small and faint, making it a challenge to observe from Earth. This makes it difficult to see from Earth, but not impossible. But with powerful telescopes, astronomers can just make it out, revealing its secrets bit by bit. By studying Philophrosyne, we can learn more about the history of our solar system and the processes that shaped it. We can also learn how Jupiter's moons came to be and what they can tell us about the formation of planets and moons. In 2003, a team of astronomers found Philophrosyne. They were using a powerful telescope on Mauna Kea in Hawaii. This telescope is one of the largest in the world. Even with this powerful tool, it took many years to confirm the discovery. Philophrosyne is just that faint. The astronomers who found Philophrosyne gave it a temporary name. They called it S2003J15. This name just means it was the 15th moon of Jupiter found in 2003. But in 2019, the moon finally got its official name. It was named after a figure from Greek mythology, Philophrosyne. She was one of the Charites, goddesses of charm, beauty, and grace. Philophrosyne is a small moon. Astronomers think it is only about 2 kilometers wide. That's less than half the size of the Grand Canyon. Because it's so small, Philophrosyne has very weak gravity. It's not strong enough to pull the moon into a round shape. Philophrosyne is also very dark. It reflects very little sunlight. This is probably because it is covered in carbon-rich materials. These materials absorb light instead of reflecting it. This makes Philophrosyne even harder to see. Section 4. A retrograde dance. Philophrosyne orbits Jupiter at a great distance, far beyond the reach of the planet's main ring system. It takes this tiny moon about 701 Earth days to complete one orbit, which is quite a lengthy journey compared to our own moon. That means 1 year on Philophrosyne is almost 2 Earth years long. Imagine celebrating your birthday only once every 2 Earth years. What's even more interesting is the direction of its orbit, which is quite unique among Jupiter's many moons. Philophrosyne orbits Jupiter in the opposite direction to the planet's rotation, a phenomenon known as retrograde motion. This is called a retrograde orbit, and it's a fascinating aspect of celestial mechanics. Astronomers believe that moons with retrograde orbits were probably captured by the planet's gravity rather than forming in place. Philophrosyne is part of a group of moons called the Pasiphae group, which all share this intriguing retrograde motion. All of these moons share similar retrograde orbits, suggesting a common origin. This suggests they may have once been part of a larger object that broke apart, scattering pieces that became the moons we observe today. Section 5. Unlocking the secrets of the solar system. Even though Philophrosyne is a small and distant world, it can still teach us a lot. This tiny moon, orbiting far from the bright glare of Jupiter, holds secrets that can unravel the mysteries of our solar system. Studying this moon helps us understand how Jupiter's incredible system of moons formed. Each moon, including Philophrosyne, plays a part in the grand cosmic dance, revealing the processes that shape these celestial bodies. It also provides clues about the early solar system. By examining the orbits and compositions of these moons, scientists can infer the conditions that existed billions of years ago. For example, the capture of Philophrosyne and other moons like it tells us that our solar system was a very chaotic place billions of years ago. The gravitational interactions and collisions were frequent and intense, There were many collisions and interactions between different objects. These events played a crucial role in shaping the planets and moons we see today. By studying these ancient collisions, we can piece together the history of our cosmic neighborhood. Each piece of data adds to our understanding of the solar system's evolution. Philophrosyne may be just one small moon, but it holds big clues to the history of our solar system. Its story is a chapter in the grand narrative of how our cosmic neighborhood came to be.